Okay, 59 says identify the quadrant or quadrants for the angle satisfying the given conditions. So in order for tangent, so like if you think about it as you move around your quadrants, right? There's actually an acronym all students take calculus that helps you remember which are positive. So those are for your initial 3, sine, cosine, tangent. If I'm in the second quadrant, the y is positive, which makes sine positive. I'm in the third quadrant, the y and the x are negative, so the only thing positive in there is the tangent. And then in the fourth quadrant, you're moving to the right, but you're moving down, which means the x is positive. But the y, which would be the sine, would be negative. So if I'm looking for where tangent is greater than 0, it happens 2 places. It happens in this first quadrant and it happens in the third quadrant, right? Everything's positive in that first one. Tangent would be positive in the third one because you're moving left and down, so both the x and the y are negative. Then it says cotangent is also greater than 0. So wherever tangent is positive, cotangent is positive, which means it's the same 2 quadrants. So it would be quadrant 1 and quadrant 3. Does that make sense?
Yeah, so for 57, because it's both of them.
So sine is positive, right? And sine would be positive here and here, right? Because it's the y, so only in the top. And cosine is negative. Cosine would be positive in the first quadrant, so we rule that one out. Cosine would be negative in the second quadrant because you're moving to the left. So this would just be quadrant 2.
For those, can you also just like kind of like estimate that like sine is like 1 and then like cosine is like less than 1? Since it says like cosine is less than 0 and sine is.
Oh, like can you give it a value, you mean? Sure. Yeah. It's usually referring to the positive and negative. So just give whatever that value is, that sign. I mean that value, yeah. I mean the positive or negative sign. Any other questions on the homework? Yeah.
What do you do for the possible and impossible?
So possible, remember possible would be like cosine and sine. They have to be less than or equal to 1. So if it's something like cosine is, and it's positive or negative 1, right? Because it can't be, it would be in between those. It can't be smaller than negative 1 and it can't be bigger than positive 1. So that's where this one would be impossible, right? And then tangent and cotangent, these can be anything. So those are both possible. And then here, yeah, these would both be possible because tangent and cotangent can be bigger than 1. But sine and cosine cannot. Can't be smaller than negative 1 and can't be bigger than positive 1. Because then you're saying the hypotenuse is not the longest side. Other questions? Yeah.
There's only 2 there, right?
Only 2. You mean sine and cosine, like the limits on them? I mean, the reciprocal functions then change too. Yeah. But yes, those are the only ones that can't be bigger than 1.
The reciprocal functions are the same thing as that?
No, because you'd be flipping it. Yep, so it'd be the opposite. Yep.
And then can you also do number 49?
Yeah. Okay, so it said use of the appropriate reciprocal identity to find the function, rationalize denominators when applicable, and then this one said to use the calculator on it. So if secant is 9.8 whatever, then cosine would be the reciprocal of that. So this would be 1 over 1, and then in the calculator you would do 1 divided by that whole thing. So you're just flipping it. Most likely, a question like that on the quiz, you would have it exact, where you'd have to just flip the fraction. Yeah. Not use the calculator.
And then for that one, you wouldn't put it as negative, it would just be.
It's not negative, right? It's just the reciprocal, not the opposite sign. All right, so this one says find the trig functions for the values of each angle. And then it says, the calculator was for the ones that weren't on here. So for 89, it says tangent of theta is the square root of 3 with theta in quadrant 3. So the fact that it's in 3 tells you like about your signs, right? So that means I'm moving back and I'm moving down. So I'm going left, which means it's going to be a negative x, and down, which means it's going to be a negative y. And then my theta would be in here. Tangent root 3 would be over 1, right? Like if the denominator was there, it'd be over 1. So this is opposite over adjacent, or the y over the x. So it's root 3 and over 1. they both get the negative because it's in the third quadrant. So then to find the missing side, you can do the Pythagorean theorem. So -1 squared, and the sign doesn't matter because we're going to get rid of it when we square it. Squared plus the square root of 3, negative square root of 3 squared would equal your radius squared. So I'd get 1 plus 3 equals r squared. R squared is going to equal 4. So r would equal the square root of 4, which is 2. Now you've got all 3 side lengths. And then it says find all the trig functions, right? So I got to do sine, cosine, tangent, which is the one you have, root 3. And then cosecant, secant, and cotangent. So sine would be negative root 3 over 2. Cosine would be -1 over 2. Tangent we have. And then we flip them. So when you flip negative 2 over root 3, that has to get rationalized. So I'd get negative,
Oh yeah, I think I missed
the rationalizing, yeah. And then this would be -2. And then this one would also have to get rationalized because it's 1 over root 3. So these are like, that's why it's almost dangerous to have your calculator for the questions because this has to be exact. So all of that has to be kept that way. You don't use the calculator to get like the square root of 3. So just be careful and use them only when you need them.
How do you know where the theta goes?
It's always, so if it gives you the quadrant, right, that helped me put it in the quadrant 3. It's always the angle from the x-axis to wherever your terminal side is. So if it's in the 4th quadrant, it's here. If it's in the 2nd quadrant, it's here. If it's in the 1st quadrant, it's here. So it's always from the x-axis to the terminal side of that angle.
Okay.
Never here. Never on the y. Any other questions from the homework? So,
I'm not seeing one. How do you know to put the root 3 there?
how do I know to put, oh, because it's like tangent, SOHCAHTOA. So opposite over hypotenuse. Sophie.
Can you do 81 and 83?
All right, 81 says find secant if the tangent, oh, that's a 3. It got cut off, but that's a 3. With theta in quadrant 3. So again, 3 means I'm moving left, so it's -x, down -y. And the tangent would be opposite over hypotenuse. I mean, opposite over adjacent. So 7, root 7, and 3 would be there. And then to find the missing side, I would do square root 7 squared plus 3 squared equals r squared. This is 7 plus 9. R squared is 16, so r equals 4. Remember, the hypotenuse is always positive. And then because it's secant, this would be the reciprocal of cosine, right? Cosine is adjacent over hypotenuse, so the secant would be the hypotenuse over the adjacent side. Hypotenuse is 4. Adjacent is -3. And then you said 83 too, right? So 83, now you're finding sine if secant is 2. So this would be 2 over 1 if you had the fraction. It's in quadrant 4 this time, so I'm moving to the right, so it's a positive x, but I'm moving down, so it's a -y. Secant would be the reciprocal of cosine again, so this is hypotenuse over adjacent. Hypotenuse would be 2, adjacent would be 1. To find that third side, I got to do the Pythagorean theorem. 1 squared plus x, or actually it's y, but 1 squared plus y squared equals 2 squared. 1 y squared would equal 3, and y equals square root 3. And then it's negative because we're in that 4th quadrant. So the sine would be the opposite side, which is the root 3, negative root 3, and the hypotenuse is 2. Yeah. So your quiz review, we're gonna go through a couple of examples on the sides of these, okay? But then you're gonna work on this. So in 5.1, we talked about our coterminal angles, right? You talked about, I'm struggling here, hang on. We talked about how to graph these angles, so you're gonna get the same thing. It'll say draw the angle in standard position and then find coterminals. So our coterminals, if we're finding in degrees, we would add and subtract 360 degrees. Remember that the positive coterminal has to be positive, the negative has to be negative. So sometimes we're gonna do this more than once. If it's negative 625, you're obviously going to have to add 360 more than once to get it to be positive. So you're just going to keep adding, okay? And if it was really high, like if it was positive 625, you're going to have to subtract 360 more than one time to get to the point that it's negative. So positive has to be positive.
Are we gonna have to give the lowest one possible to negative?
No. You can give more than one answer. I would take more than one answer there. Then it says draw the following angles. So remember that when you're starting off, we say this is 0. This would be 90 degrees. This would be 180 degrees. This is 270 degrees. And it doubles back around here to 360 degrees. So if I'm just graphing something like 150, I'm going to go midway between the 90 and the 180, okay? If it's negative, you go the other way. So if it's a negative, let's say it's a negative 100, okay? You had two options when you're graphing the negative. One is go clockwise, so I would start it here. This would be a negative 90, which would take me just past it. And that would be negative 100. So that's one way to draw your negative angles. The other is draw it as it's positive. So a positive 100 would be up here. And then fold your graph at the x-axis. And wherever that line overlaps is where it would be negative. So both answers would give you the same end, which would be this angle here. If you're doing negative, I need you to put that arrow. So like if it was positive, I assume you're going in the positive direction. You don't have to give me the arrow, okay? But if it's negative, if you're changing the direction, you got to make sure you give that arrow. And then something like negative 425, obviously it's a coterminal, right? It's bigger. So you'd have to go around your unit circle or your circle one full time, and that would be your 360. And then you have to go past it till you hit that negative 425. So let's say it was negative 410 degrees. If I took the 360 out of here, there's leftover of 50 degrees, right? So negative 360 would go all the way around my circle one full time. And then the 50 degrees past that would take you a little bit further, and your negative 410 would look like that. You could have also drawn it as though it's a positive 410 and then folded it over on your x-axis.
I have to show the circles.
If you're going negative, yeah. All right, then for 3, we're converting from decimal degree to degree minute second notation. Remember for this one, we would take, so if it's, let's say it's 45.745, okay? We would take the 45, that's the whole number part of this. That would be your degree. And then you take the 0.745, you multiply it times 60. Didn't get my calculator out. You take the whole number portion of that, and that's your minutes. And then you do it again with the decimal, and that's your seconds. So this is 44.7, then that's 44 minutes. And then I take the 0.7 and I multiply it times 60 again. And that's 42, and that's my seconds. If it starts negative, like the negative 47.275, then my answer is also negative. You just put the negative on this sign. The second one, or the next one, is converting to decimal degree. So now we're in degree minute second notation, and we want to go to decimal degree. So if it was 45 degrees, 44 minutes, and 42 seconds, we keep the 45. That's the whole number part of this. And then we would take the 44, divide it by 60, and take the 42 and divide it by 3,600, and then add all those together. So 44 divided by 60 is 0.73 repeated. 42 divided by 3,600 is 0.0116 repeated. So add those all together, and I'd get 45.744967, whatever. And it will tell you what to round to. I think it's hundredths. No, I think it's thousands. So you'd go 3 decimal places. questions on those, yeah.
For the one where you convert it to degrees, minutes, seconds, do you put the decimal?
Do you put the decimal, like at the very end, you mean? Like if this one had a decimal? Yeah.
Do you round it?
I don't know that it says it on there. What to round to. Hang on, I'm looking. Yeah, it doesn't. I would say 10th on that, so I'll have that instruction on. Yeah. So 10th on the seconds. Questions on the converting? Yeah.
If it cancels out the first take, do we put a 0 for the second takes?
You don't need, if it's at the end one, the last one you don't need. So like if there's 0 seconds, you don't need it. If there was like on the calculator, if you're using the calculator feature and you don't need it, but if you're using, like let's just say it said 67 degrees and 42 seconds like that and it skips the minutes, if you're using the conversion feature on the calculator, you have to put the 0 in.
Or something like that, it goes in a-
No, there's parts of, yeah. But if you see that, you have to put the 0 in. It will give you an error. Like it'll yell at you. All right, so then the second page, starting with number 5, now you've got your coordinate points that are on the terminal side. So from these, we would set up our triangle. We would set up our triangle inside the circle. So if it was -4 and root 2, for example, I would go left 4, but then up root 2. I draw myself a triangle. I use the Pythagorean theorem to find the missing side. Remember, the radius is always going to be positive. And then you would set up your 6 trig functions. Sine, cosine, tangent, using opposite over hypotenuse, adjacent over hypotenuse, opposite over adjacent, and then just flip them to get the reciprocal functions. 6 is the same thing. Set up your triangle. Make sure you're paying attention to those signs there. And then find the missing side, and then find the 6 trig functions. So SOHCAHTOA is your magical word, right? Or the x is the cosine, the y is the sine, that kind of thing. All right, so then 7 and 8 both give it to you in terms of, so this is like the homework. It gives it to you in terms of a ratio. It's going to give you one of the trig functions, and then you have to set up your triangle based on that. So let's just say this said -√3 over 2, okay, as for cosecant. So that means that sine would be 2 over √3. That doesn't work because that's not big enough. Hang on. Make that 5. Wait, I just did the same thing. Flip that one. Okay, let's just say it had that so that when you flip it, it's √3 over 2. It would be negative. The sign's got to stay with it. So then you know you're going to the left. Well, it also has to give you, this is just the reciprocal function. You just flip it. Same thing here. These are just reciprocal ones. So remember, sine goes with cosine. Sine goes with cosecant. Secant goes with secant goes with cosine, and tangent goes with cotangent. So you just flip those. Reciprocals. Later on, when you get this, something like that, then it's going to give you the quadrant. So if it gives you what the sine, the cosine, the tangent, whatever that is, and then it gives you the quadrant, this is when you want to make sure you draw it out. So if I said, let's say it was just this. So let's say it said sine was -√3 over 2, and let's say it said it was in quadrant 3. So I know I'm going to go left and down. My theta goes in the little corner. This would be opposite hypotenuse, so this would be √3 and 2. And I know it's in the third quadrant, so the √3 gets the negative, and my missing side here is also going to get a negative. So I would do x squared plus -√3 squared equals 2 squared, x squared plus 3 would equal 4, x squared would equal 1, and x would equal the square root of 1, which is 1. It's in the third quadrant, so it's negative. And then from there, you can find all 6 or all 5 remaining trig functions. So that's what I meant by those questions are going to have multiple parts. Like that one question technically has 6 answers. Questions on that? All right, and then 10 is just like the last one. Set up your triangle. Just remember that this would be over 1 because that's the missing side length there. And then we got to Pythagorean identities. So remember these are sine squared plus cosine squared equals 1. Actually, I'll put theta because that's what your initial sheet said. If we took and divided them all by sine, we'd end up with 1 plus cotangent squared equals cosecant squared. If we had divided all the originals by cosine, we'd get tangent squared plus 1 equals secant squared. So those are your other reciprocal functions. Pythagorean identities. So when it gives you something like 11, if it gives you cosine and it's asking for cosecant, we're going to use, so you want to use the one based on what they give you. Based on what they gave me, I would use sine squared plus cosine squared equals 1. I'd plug in for cosine, square it, solve for the sine, and then because it's cosecant, I would take my sine and flip it at the end. For 12, you're given cosine again. This time it wants tangent. So you're going to take that cosine, you're going to solve for sine, and then tangent is sine over cosine. So you can literally take what you get for sine and put it over what you got given for cosine. So those you're going to use your Pythagorean identities on. So squaring. Questions for me on anything before I let you work on it? Yeah. Yeah, so let me give you a different value so that I don't. So let's say it said cosecant. Which one? Doesn't matter? Okay. Let's just say it said that. So you're finding cosecant and you're given cosine. So sine squared plus cosine squared equals 1. So sine squared plus 1/3 squared would equal 1. Sine squared plus 1/9 would equal 1. Subtract the 1/9. This would be 9/9 minus 1/9 or 8/9. And then you'd square root them. So the sine would equal the square root of 8 over 3. This actually becomes 2√2 over 3. And then it says, so that's the sine, but you're actually looking for the cosecant at the end. I'd have to take this and flip it. So it'd be 3 over 2√2, and then it has to get rationalized. You'd multiply by √2. This becomes 2, so that's 4. If it gave you, let's say, the same information, but it wants tangent this time, I would have done the same beginning part. I would end up with sine being 2√2 over 3, and then tangent is sine over cosine. So I'd have to put 2√2 over 3 over 1/3, and then flip it. So it becomes 3 over 1. These cancel, and my answer is just 2√2. So you have to pick the Pythagorean identity, God bless you, equation based on the information you're given, and then depending on what they ask for, you might have to do something different with it.
So on the quiz, it's not to have like the less than ones that we have it like the one.
Right. Yeah. Yeah.
Do we have to memorize it?
Mm-hmm.
So right now, like any symbol sheet or
Mm-mm. I mean, you know most of it. You know your reciprocals and all that stuff. It's literally these 3. And remember, if you forget, as long as you remember the first one, you can derive the other ones. Take them all, divide them by sines, and you get the first one, or the second one. Take them all and divide them by cosines, and you get the bottom one. So it's better if you can just memorize all 3. But if you can't, you can memorize the first one, and then you can figure out the other 2. We good? Yes? Okay. I'm going to let you work on your quiz review, obviously.